Welcome to Study Loop.
This is the answer to Chapter 23, problem number 55 from the Smith Organic Chemistry textbook. This problem talks about Clopidogrel or Plavix. And so we're given this reaction for part A, and we're asked what is the structure of the drug. And then for part B, we're asked to fill in some intermediates and identify the configuration of the enantiomer that we make by that part B route. Okay, so for part A, basically we have two chlorines that could react to give us our final drug here. However, the bottom chlorine is a halogen on an sp2 hybridized carbon. It's in an aromatic ring, and so it's not going to react. And so it's the top the top chlorine that's going to react, and the nitrogen in the other part of the molecule is what's going to act as the nucleophile. And so our structure is going to look like this. And this is the racemic drug. So there's not going to be stereochemistry here in part A. Let me move this down just a bit. Okay, so there's not going to be stereochemistry here in part A. And so we will end up with just this. Okay, and so there's the racemic form of the drug. So for part B, we have to identify these intermediates. And so the first intermediate B, if you look at the reagents that are being used to get from A to B, this is an esterification. And so we're making the methyl ester. Okay, so we've made the methyl ester there in B. Then in C, or to get from B to C rather, we're using tosyl chloride and pyridine. And hopefully everyone knows these are conditions for tosylation of an alcohol. And so that is going to be what happens in this step. And of course, the reason for doing that is to turn an alcohol into an easily displaceable group for an SN2 reaction. And so that is what's going to be happening next. So this is just going to be an SN2 displacement. And so I've drawn the product here except for the methyl ester because we need to think about the stereochemistry there. And so it's on a wedge here, but it's taking place. Well, let me say the carbon that it's attached to, the methyl ester is attached to, is the substrate for an SN2 reaction. And so the stereochemistry is going to invert. And so although it's on a wedge in molecule C, it's going to end up dashed here in the final product. And we're asked to identify whether that's R or S. And so the way that I've always been taught to do that is to consider what the groups on the carbon in question are. And so for the carbon in question, that would look like this. And then if we have a hydrogen, we want to visualize that on the dash. So here it's on the wedge. So that's fine. It just means that when we assign our stereochemistry, we will then take the opposite of what we get. And so I was always taught to do this in terms of like assigning priorities based on atomic number. And so we have a bond to a nitrogen, so that's going to be number 1. Then we have a carbon that is bound to 2 oxygens versus a carbon that is bound to 2 carbons. And so the carbon that is bound to 2 oxygens would get priority 2, and that would make this carbon bound to 2 carbons priority 3. And so going from 1 to 2 to 3, that's a clockwise movement. So that would be R. However, as I said, because we have the hydrogen on the wedge here, we're going to have to take the opposite of that. And so this enantiomer is the S enantiomer. So it's the S configuration. Okay. And so that is the answer to chapter 23, problem number 55.